Chapter 6.7 Model Exponential Growth and Decay. And the question states, a doctor prescribes 175 milligrams of a therapeutic drug that decays by about 30% each hour, and then we give him 4 parts of the question, actually 5 parts of questions to answer. So, let's look at Part A. Part A asks, what is the half-life of a drug? The drug's half-life is about blank hours. If you guys remember, the equation for exponential growth or decay is going to be y equals to initial times e to the rt. The y is going to be the value remaining after a certain time, and then a sub 0 is the initial, e is the exponential constant, r is the rate, and t is the time. Let's look at the important numbers in this question. So we have the initial, which is 175 milligrams, and then that decays about 30% each hour. So we're given that the time is going to be t. The time is going to be 1 for each hour, and then the rate is what we're trying to find in order to find half-life. And then we're given the a of t, also the y, is going to be 100 minus 30. 100 is starting and 30 is decaying by 30%. So you're left with 70%. And then 70% of initial can be written as 0.7 of initial. Alright, now let's plug these values back to the equation. So y is 0.7 of initial equals to initial times e to the r, and then t is 1. So we can just ignore that for now, because any number times 1 is the number itself. So we can divide both sides by the initial value. So these go away. So you're left with 0.7 equals to e to the r power. And whenever you see a e, you should immediately think of the natural log, its opposite. So let's take the ln of both sides. So we have ln of 0.7 equals to ln of e to the r. And ln e cancels out. So you're left with this. And then if you plug ln 0.7 into the calculator, you will get r equals to negative 0.3566. So this is only parts of the problem. Now we have to find the half-life time. So we're trying to find t. And then we're given the r is negative 0.3566. And then the a of t, also the y, is going to be 0.5 of initial because that's asking for half-life. So now let's plug these values back to the equation. So we have 0.5 initial equals to initial times e to the negative 0.3566t. As we did before, the initial values cancels out. And then you're left with 0.5 equals to e to a negative 0.3566t power. And then take the ln of both sides. So ln 0.5 equals to ln of e to the negative 0.3566t power. And these goes away. And then you have ln of 0.5. And because we're trying to find t, we're going to divide both sides by negative 0.3566 equals to t. And then if you plug that into your calculator, t will equal to 1.94. Redo. So the answer for part A is going to be 1.94 hours. Part B asks us to write an exponential model representing the amount of drug remaining in the patient's system after t hours. So if you guys remember that the equations is a of t equals to initial times e to the rt, right? And then so the initial value is 175 milligrams. So 175 times e to the r. R is the value we found in part A, which is negative 0.3566, and then t. So that's the answer for part B. Part C wants us to use the formula from Part B to find the amount of drug that will remain in the patient's system after 3 hours. So we are going to plug it into the equation of Part B. So we have 175 times e to the negative 0.3566 and then 3 hours. So if you plug that into your calculator, it's going to equal to 60.02 milligrams. Part D, it says find A of 8 and interpret the result. So pretty much this is A of t. So the A will mean 8 hours. So we're going to do the same thing as we did in part C. So we're going to plug in 8 for t. So we're going to have 175 times e to the negative 0.3566 times 8. And if you plug that into your calculator, your answer will be 10.09. So it wants us to interpret the result. As we said before, the A, is going to equal to 8 hours. So you're going to look for 8 hours. This is saying 8%, so this is wrong. And then this is 8 milligrams, which is also wrong. And then so you have 8 hours, 8 hours. And then remember we said that A of t is the amount left, the remaining. So it's not the percent. So this is also wrong. So the answer is going to be the third choice.